Hi everybody, hope you're having a good afternoon. Is that better? I said good afternoon, so. So I'm presenting another one of the conceptual models following on from Jane and Murray, and this is the pesticide one. My plan was to actually do the presentation through the website, but the technology didn't quite align with that idea. So what I've done instead is I've put the website address up there. So I know a few of you probably have laptops. So if you want to put that address into your web browser, you can probably follow along with me, and that way you get to see how the links work and the little pop-up boxes and so forth along the way, which I can't do in a PowerPoint presentation. So while you're doing that, I will tell you all about the team that worked with me on this. The Satchel Project was a little bit unexpected, as pesticides and other contaminants wasn't actually one of the themes of the NESP synthesis projects, but it did get funded through that, through those projects, and because there were already the sediment and the nutrient conceptual models being undertaken, there was some agreement that there should probably be a pesticide one as well. So Jane asked us very kindly if we would, this group of us would work on a conceptual model for the pesticides, which we did very passionately and maybe a little bit too passionately sometimes. There was a lot of detail that Jane and Kate had to deal with. So we had there Michael Warren from the University of Queensland, Andrew Negri, who's actually going to present some pesticide research that is covered in this conceptual model straight after me. Rainier Mann from the Queensland Department of Environment and Science, Adam Northey from Queensland Department of Ag and Fisheries, Janine Knight from the Australian Pesticide Veterinary Medicines Authority, myself, I'm from the Office of the Great Barrier Reef, Kate Hodge, who is the lovely designer of the conceptual models, and of course Jane, who managed to keep us in line and make sure we actually delivered it on time. So that's the team. Have you been successful in, or did I not leave the website on long enough? No. Can I go backwards? There we go. Hopefully that everyone going on to this at the same time isn't going to crash it as well. I'm not sure if Kate prepared for it going viral all of a sudden. While you're doing that, I will just give you a little bit of background about myself. I would be probably considered now in my role with Office of the Great Barrier Reef as an end user of science. I do have a science background, but these days I work in a small team, and we deliver big projects that really largely depend on scientific evidence for those deliveries, and that includes the Reef Water Quality Report Card and the Scientific Consensus Statement. And the consensus statement's been mentioned a couple of times already today, and we're just starting in the planning process for the next one to be delivered in 2022. And so this is really great timing, the finalisation of all these NESP research projects and how they might be brought into the next consensus statement. In particular, I think these products, these conceptual diagrams and the NESP synthesis projects will help considerably as well in that process. I think I might move on now. I think, is everybody... Oh, did it crash? Oh. Keep persisting. So the broad aims of this particular conceptual model, and I think probably all of them, was to develop something that told the story of science on these particular themes, and to demonstrate where that NESP research fits into that story. In particular, providing where NESP research provides the key evidence. to support better decision making. So that real focus on applied research for the end user. We also wanted to make sure that, and we did try hard, and hopefully we did manage to pull it off, we wanted to make sure that this was in a format that was not too complicated, could be understood by a non-technical audience, particularly coming from my background, keeping in mind the needs of the end users who don't necessarily have the time to go into all the detail. But we also wanted to make sure that it was a platform that was almost like a central house from which you could find the links to find the more of the information and the detail that you needed. So I will go into what the website looks like, and this is the landing page for the Pesticides and Other Contaminants conceptual model, and in the same vein as the nutrient and sediment ones, it's a landscape-based diagram which shows the pesticide and the story of the pesticides and other contaminants. Embedded in those, do I have a pointer? Oh, yes, I do. Embedded in these are a couple of case studies. So if you hover over those, if anyone's actually managed to get onto the website, you can hover over those. They're clickable, and that will actually bring up more information on those case studies. We have two. One is the Fly River, which I won't discuss today because, Jane, you're talking about that tomorrow, is that right? And another case study on pesticide management. These magnifying glasses, when you hover over those, that should bring up a little bit more detail about those particular parts of the model as well. When you scroll down, you'll get a written narrative describing the story of that diagram, plus you'll get those links to the NESP research that fits into this conceptual model. If you scroll back up, if you're on the website, if you scroll back up to the diagram, I'll just quickly run through that to explain that story. One of the NESP projects that fits within this conceptual model is the Emerging Contaminants project, which was led by Frederica Kroon from AIMS. That project largely was demonstrating that we probably have very limited evidence on emerging contaminants, particularly for those Great Barrier Reef waterways. And they looked into potential sources and potential risks. I think one of the main outcomes of that was that we need to invest a lot more into understanding that a lot better. The model also here is focused on pesticides, obviously. Pesticides are an important tool in modern farming systems, particularly in cropping and also other land uses. But under certain conditions, those pesticides can run off the paddock and enter waterways. And what we're trying to demonstrate here is the potential sources and transport pathways in which that occurs. What you can see from those yellow arrows there is what we're trying to represent is that the concentrations generally closest to the source of the pesticides are usually the highest, and as they are transported out towards the end of the catchment and then out into the marine environment, they generally dilute. Andrew Negri then also undertook some NESP research under the Cumulative Impacts Project, and you can see, you can see some symbols there representing other stresses, and he looked into how that other stresses might change the effects of the pesticides. One of the big complications of managing pesticides is the mixtures that we detect. So as you move down the catchment and you move past many different land uses or different farms, there are a number of different pesticides that are used, and these can transport off the paddocks and come together, and you get mixtures of pesticides. And this does present itself as a bit of a challenge when it comes to managing and setting targets for pesticides. So now I'm going to talk more about this case study that we did for managing pesticides. So if anyone is on the website, what you can do to get to that case study is there's a drop-down menu at the top there, which you can click on, and you can get to the pesticide management case study there. Or if you hover over the little icon there and click on the Find Out More, you can also get to the case study that way. When you do click on those, you'll see another conceptual model, and the main aim of this conceptual model was to highlight the different management processes that we go through in terms of managing pesticides for the purposes of improving water quality. And how much we rely on research to provide the evidence for a lot of those processes. And Andrew will go into more detail about that, so I won't discuss it in too much here. On the actual website, you can scroll down to the bottom and you'll see some information describing at a kind of high level about those 4 different management steps there. So I'll just run through each of those very quickly. So the first one is the proactive risk minimisation, and this happens with the Australian government. The APVMA is responsible for this, and Janine Knight from the APVMA contributed this part of the conceptual model. And you can see there's a multi-step stage there, where this is before any pesticides are actually released to market. There's a risk assessment that's conducted, and that develops the label conditions in which a pesticide can be applied, and that is a regulated conditions. So that means that they have to use those pesticides based on those conditions that are developed there. So that's before pesticides are ever used on a paddock. So the next step then in the management process is that paddock stage management, and there's multiple stages there as well. Adam Northey from DAF was responsible for contributing this section, and through that there's a number of different stages, and that involves just the selection of pesticides, applying according to the conditions of the label. There's engagement and extension in terms of communicating with landholders about the different pesticides. There's additional steps in which you could choose a pesticide that might have lower environmental toxicity or lower mobility to actually reduce how much enters the waterways, and various practices that might help reduce pesticide runoff as well. The next stage is the investigation stage, and this is where we actually have a look to see if pesticides, after those first 2 management processes, if pesticides have managed to be transported into waterways. And this is a little bit of a complex process. It involves risk assessments, comparisons to water quality guidelines, and so forth. And I think Andrew will be talking a little bit about that, so I might brush over that. That data is extremely valuable, and the Catchment Loads Monitoring Program has collected a lot of data there, which has really helped us in terms of managing pesticides and setting targets and so forth. So once, if a risk is determined, then the next step is to evaluate the magnitude of that risk. Do we need to set targets, which we have done? And then to evaluate or to set actions, feedback to land management practices, and to evaluate and report on whether those land management practices are having an effect on at reducing that pesticide risk. In some cases, there is another loop to that cycle, and that is that the data from the investigations may also go to the APVMA, and they may use that to review those label conditions. So I'm going to finish there. Hopefully some of you managed to get onto the website and take a look, but if you didn't, the web address is there again, and I do urge you to take a look, not just at the pesticide one, but all the conceptual models there. They're a really great resource, and hopefully it's helped to communicate some very detailed and technical information into a simpler format for everyone. Thanks.